Hello friends, here is a question that cuts straight to the core of modern software. What do scikit-learn, PyTorch, TensorFlow, and Pandas all have in common at their foundation? The answer is arrays, and the aggregate operations that run on top of them. In this video, we are going to unpack exactly what arrays and aggregates are, how they differ, and when to reach for each one. These are not just theory concepts from a textbook. They are the literal building blocks every AI model running in production today depends on. Whether you are just starting out or brushing up your fundamentals, understanding this distinction will sharpen how you think about data structures for the rest of your career. Let us start from the beginning. Alright, let us define our first term. An array is an ordered, homogeneous collection of elements stored in contiguous memory. Homogeneous means every element must be the same type. Take this example. Int scores with 5 slots holding the values 88, 76, 95, 61, and 82. Each element sits right next to the previous one in memory, and you reach any element instantly using its numeric index, starting at 0. Because the type is fixed and the layout is tight, the CPU can jump directly to any element without searching. That gives you constant time access, big O of 1, for any read or write. In Python, you might write this as a list, but a NumPy array enforces the same, homogeneous, contiguous layout and adds serious performance benefits on top. We will come back to that. First, let us understand the broader category these arrays belong to. Now look at this. An aggregate is a broader concept. It is any compound data type that groups multiple values together under a single name. Arrays are one kind of aggregate, but so are structs and records, and they work differently. An array groups many values of the same type. A struct groups values that can be completely different types. Think of a struct called student with a name field holding a string, a score field holding an integer, and a passed field holding a boolean. 3 different types, one named container. The key insight is this. Array is a specific data structure, and aggregate is the category it belongs to. Every array is an aggregate, but not every aggregate is an array. With that relationship clear, let us put the two approaches side by side and see exactly where they diverge. Here is the interesting part. Once you see these two concepts side by side, the decision about which to use becomes obvious. Arrays enforce a single type across every element, and you access them by numeric index. So scores at index 2 gives you the third score, which in our example is 95. Structs, on the other hand, let members have completely different types, and you access each member by its name, like s.name or s.score. Arrays are the right tool when your data is a uniform collection of the same kind of thing. Scores, pixel values, temperature readings. Structs are the right tool when you are modeling one logical entity with multiple different attributes, like a student, a product, or a sensor reading with a timestamp. Both are aggregates. The difference is what they enforce and how you navigate them. Now let us see this in real production code. Let me show you this in action. NumPy 2.4.6, the latest release as of May 2026, is how this plays out in real production pipelines. Take our scores array from earlier. We wrap it in a NumPy array, and then a single call to np.sum collapses the entire array to one value, 402. A single call to np.mean gives us 80.4. No for loop, no manual accumulation. NumPy dispatches these aggregate functions to optimize C code under the hood, which means on a large array, they can run orders of magnitude faster than a Python loop doing the same work. This is not just a convenience. Scikit-learn, Pandas, PyTorch, and TensorFlow all sit on top of this same array and aggregate foundation. Every model you train, every feature matrix you build, flows through exactly this pattern. That brings us to the key question. How do you decide which structure to reach for? Alright, let us tie it all together. The decision rule is clean and practical. Reach for an array when your data is uniform. All the same type, accessed by position. A list of scores, a vector of pixel values, a batch of model inputs. Reach for a richer aggregate, like a struct or a record, when you are modeling one logical entity with multiple different attributes of different types. A student has a name, a score, and a pass status. A sensor reading has a timestamp, a float value, and a location string. Those belong in a struct. The deeper takeaway is the relationship. An array is a specific, index-based, homogeneous structure, and it is one member of the broader aggregate family. NumPy 2.4.6 shows you exactly how powerful that homogeneous constraint becomes in practice. Same type means the CPU can tear through data at full speed. Master this distinction, and you will write cleaner, faster code from day one. Thanks for watching, and we will see you in the next one.